Everybody, today's lesson is on segments and their measurements. Yesterday we talked about segments as being something that has two endpoints. So it has a definite length, as opposed to rays and lines, which shoot off infinitely. Rays in one direction, lines in two. But segments are fixed. So today we're going to spend just a little bit of time talking about segments and their lengths. Another really important term that we're going to be talking about today is congruency. So let me go ahead and switch over to our screen. This is just a reminder that I'm going to move things just a little bit so you can see a little bit better. There we go. A reminder that you do have the notes available to you online in the same folder that you should have found this video. So, a coordinate is the location of a point. If you've ever done anything with coordinate algebra, that XY plane, the coordinate is where it is. Distance, let me grab my finger here. Distance between A and B is written as AB. Okay? We're going to talk about distance, how far between 2 points are from each other. Length, which also is a measurement, can be taken by taking the coordinates and subtracting them from each other. And we'll talk about that just a little bit more later. Between means that it has to be on the same line as two other points, but is in, not necessarily the middle, but between those 2 points. B, for example, is between A and C. We're all on the same line, and B is between them. Okay? So if you notice here, we also have labeled AC, which is from A to C. We also have AB, which is from A to B, and BC, which is B to C. So we actually have 3 different segments here that we're looking at. Congruent segments have the same length. These tick marks are going to be super important as we talk about them. Tick marks mean that they are congruent. Congruent means that they have the same length, the same measurement. Triangles can be congruent, segments can be congruent, angles can be congruent. These are all different things that can be congruent if they have the same measurement. It means that they're basically the same. If we have a tick mark, that means that those 2 measurements are going to be the same. Now let me make myself just a little bit bigger here and do some doodling on my board. Okay? If I've got 2 segments, we've got segment 1, segment 2. A hash mark means that they are the same. But I also have these 2 other segments. And I want to identify that these 2 are congruent. Well, if I mark a hash mark through each of those, now what it looks like is all 4 of these are congruent to each other. And that's not true. These 2 are congruent, and these 2 are congruent. So I need to give these 2 a second hash mark. Okay? Everything is congruent to everything that has the same number of hash marks. So these 2 with 1 hash mark are congruent to each other. These 2 with 2 hash marks, those 2 are congruent to each other. So that's not what we're looking for. That means they have the same measurement. They are congruent. Congruent means the same measurement. And I can promise you, you will be using the term congruent from now until the end of Geometry B. So that's a really important term. We are going to be talking about congruencies a lot. It means same measurement. Let me erase this, and we're going to pop back into my slides. All right. There is a slight difference between equal and congruent. It's mostly in definitions and terminology. Functionally, they are basically the same. Length AB is equal to the length of CD as opposed to segment AB being congruent. Measurements are equal. Segments are congruent. So the measurements here, the length is equal as opposed to the segment. So the segment is the thing that is congruent. Okay? I am the same height as my brother. The height of Jared is equal to the height of Tyler. It would be weird to say Jared equals Tyler. That doesn't make sense. But talking about the length or the height of those things does. Or we are congruent. We are the same height. Our measurements are the same, which isn't true. He's way taller than I am. A little embarrassing, actually. Anyway, we've got some different symbols here. So AB equal to CD means that these two have the same measurement, but this is the congruency symbol right here. Between AB and CD, that equal sign with a little bit the squiggly up top, that's a big deal, okay? Keep that in mind because we're going to be using that symbol a lot. So be aware of what the congruency symbol looks like. The segment addition postulate, we've talked about postulates a little bit. These are things that are accepted without proof because they're very basic and are in some ways actually the rules that we're writing geometry with. So if B is between A and C, and if we look over here at the right, it is, then AC, that whole segment, is going to be equal to AB plus BC, which makes complete sense, right? If I have a ruler and I cut that ruler in like half, the length of the entire ruler will be the length of the first half of the ruler plus the second half of the ruler, okay? And that's all we're saying here. It's nothing super complicated. It's that the length of the whole segment is equal to the pieces added together. The second part is that AC is equal to AB plus BC, meaning that it is between A and C. Notice what we have here. This is coming off of our logic unit, right? That this if-then statement and the second if-then statement are the converse of each other. This is an instance where the converse is true. That if B is between A and C, then AC equals AB and BC. And remember, for the converse, we flip things. So AC equals AB plus BC, then B is between. So we have a way to prove that it's between. The contrapositive, which is also necessarily true, would be if AC does not equal AB plus BC, then B is not between A and C. So find the distance between 2 points. We are not going to spend a bunch of time with rulers in this class, so we're actually going to skip over this. All right. Again, measurements that we skip. Here we go. Distances on a map. Okay, so if we are going from Athens to Albany, and you can see this on your screen, Athens to Albany, Athens to, I don't actually know what that is. Macon, maybe? I don't know. But Athens to Macon, or A to M, is 80 miles. Macon to Albany is 90 miles. So, because they lie on a line, we can use that postulate that the two pieces of a line equal the length of the whole thing. So, AM from A to M is 80 miles. From M to B is 90 miles. AB must equal AB plus MB. Therefore, the distance from Athens to Albany is 170 miles. Here we can find a distance by subtracting. So, in the last example, we gave you two pieces and asked you to find the length of the whole. Now what we're doing is we're giving you one piece and the whole and asking you to find the length of the other piece. Well, we know that we can add these together by that segment addition postulate. So DE, which is 10, plus something we don't know, I like to say it's X because I prefer that variable, 10 plus something equals 16. We see that in the second step here. 16 equals 10 plus EF. We'll subtract 10 from both sides. That missing segment is going to be 6. Which can make sense. 10 plus 6 is 16. The lengths of the pieces, when added together, will give you the length of the whole. We're going to skip over checkpoints just a little bit. We're going to talk about them, though. Looking at ABC, we know that AC is going to be the length of both pieces, so 14 plus 6 is 20. And looking over here at SR, we know SR is 23, TR is 15. So what do we need ST to be so that that whole distance will equal 15 plus X? ST will have to be 8. 15 plus 8 equals 23. We are going to, for now, skip over. You know what? No, we're not. You actually need to know this stuff. The segment shown in the coordinate plane congruent. So, let me talk about DE first. D to E. We notice that this is 3 up. 1, 2, 3, and that's our Y. But from X to X, -3 over to 1, that means we have a length of 4. And we can count this. 1, 2, 3, oops, 1, 2, 3, 4. Sorry. Start with the first thing. So that's a length of 4. Down here, 1, 2, 3, 4. Both of those have a length of 4. And we can also use subtraction here as well. 1 minus -3 is also going to give us 4. So in both cases, we have a distance of 4. If their lengths are the same, then they must be congruent. And we got that very fancy congruency symbol. Let me move myself out of the way. We got that very fancy congruency symbol there. DE, congruent to FG. We are going to stop there, I think. Yep, that's not actually a assignment. So, if you jump out of this video, you'll see that the notes are posted, and there's also an assignment ready to go. It'll be similar to yesterday, some images, some fill-in-the-blank questions. Tomorrow, we're going to be looking at some angles, and I will see y'all in class.